All right, kiddos, we're going to finish up our lesson on the law of sines. The previous video, we did the law of sines when we had a triangle that was angle, angle, side, or angle, side, angle. Now, the next triangle we're going to talk about is going to be side, side angle. Now, a side, side angle, you have some special circumstances going on. When you have side, side angle, you can have one triangle like we did on the previous lesson. You can have two triangles. Now, two triangles might look like a triangle within a triangle, okay, where you have two angles here and two angles here and then one angle here. Or you might not be able to make a triangle at all. So these are what we call ambiguous cases, okay? So with side, side angle, you can have one triangle, two triangles, or no triangle at all, okay? And I'm going to show you each way to solve those. Now, on your haiku page, I gave you some tips, okay? It's a Word document. The Word document shows you what to do or how to go through the steps to figure out if you have one triangle, two triangle, or no triangle. So if you will print this off and look through it as you're solving these problems, it may help you a little bit. It's no guarantee, but it's something to look at, okay? So those are your steps that you can go through. Now, again, I'm going to go through each type with you. I'm going to do one triangle, two triangles, and no triangles. Okay, now the little notes that you have up here at the top, it tells you the sine function has a range between -1 and 1. That's why on your steps here, step 2 tells you to divide out the sine of x to make sure it's between -1 and 1, because if it's not, you're not going to have a triangle, okay? And then the next thing it tells us, if the sine function is positive, then the angle is going to be in quadrant 1 or 2. To find the other possible angles, we can subtract from 180 degrees. The sum of the angle measures in a triangle is always 180 degrees. And no triangle can have two obtuse angles, okay? So, let's look at number 7. Now, we have a triangle. It doesn't give us the triangle, so we're going to draw it ourselves. So, A, B, C, A, B, C. So it tells us that angle A is 50 degrees. Let's fill that in. It tells us that AB is equal to 4. So this is AB, so that's actually side C. And then BC is 9, so that's actually going to be side A. So looking at this, you'll see that you have side, side, angle. Anytime you have side, side, angle, you've got to be prepared for one triangle, two triangles, or no triangle at all, okay? So we're asked to find the measure of angle C. So this is what we're looking for, okay? So let's set up our proportion. Notice we have no part of B. We just have A and C. So we know that the sine of 50 degrees is going to be over 9. Okay, and then we're looking for C, so the sine of, you can put angle C or you can put X, whatever you want to do, is going to be across from or over 4. So just like we did in the previous lesson, let's do a cross product. We'll have 4 times the sine of 50 degrees is equal to 9 times the sine of C degrees. Now to solve for the sine of C, let's divide both sides by 9 to get rid of it. So now we have the sine of angle C is equal to 4 times the sine of 50 degrees over 9. Now, after we've set up our ratio, that's step 1 in your steps, it tells you to divide this out and make sure it's in between -1 and 1, because if it's not, you're not going to have a triangle. So in our trusty calculator, we have 4 times the sine of 50 degrees, okay, and then we're going to take that and divide it by 9. So do you see how it's in between -1 and 1? I'm going to write this down. The sine of C, I'm going to go out 4 decimal places. 3405. Okay, so this is the sine of angle C, but we don't want to know the sine of angle C. We just divided this out to make sure it was in between -1 and 1. Since it is, that tells me that I have a triangle. Okay, so now I'm actually going to find angle C. To find angle C, I've got to go from the sine back to the angle. That's where our inverse function comes in. So we're going to find the inverse of that 0.3405. Okay, so second sine is our inverse function. I'm just going to go up here and highlight this and hit enter. Okay, now this is an angle measure. So I'm going to do 1 decimal place again, and that'll give me 19.9 degrees. So angle C is equal to 19.9 degrees. Since this is an angle, it should have a degree symbol behind it. Okay, so this is my one solution. But remember, with side-side angle, we can have 2 solutions. So I'm going to find my proposed angle C1. To find that, I'll just do 180 minus 19.9. Okay, so 180 minus 19.9 is 160.1. Okay, I know this is an answer. Okay, I've done this one. I've found my sine in between -1 and 1. This is a definite angle, so a definite triangle. This is the one I'm unsure about, this second angle C. So what I'm going to do is I'm going to make sure that it makes a triangle. So a triangle is 180 degrees, and I'm going to subtract 160 and 1/10 and the original angle that I was given, which is 50. Okay, so if you do 180 minus 160 and 1/10 minus 50 degrees, you're going to see that this is a negative angle, -30 and 1/10. You know that's not possible, right? So if you take your second angle and you check it to see if it actually makes a second triangle and you get a negative value, that tells you that you only have one solution for your triangle, which is 19 and 9/10 degrees. Okay, so going through the steps, step 1 on your Word document tells you to set up a ratio. I set up my ratio and I solved for the sine of x. In this case, it was the sine of angle C. And I divided it out for step 2. Since it was in between -1 and 1, I went to step 3, which is to find the inverse sine of this angle so that I would know what my angle C is. My angle C is 19.9 degrees. Step 4 tells me to take this angle and subtract it from 180 to get a possible second triangle angle. Then step 5 says to check this angle to see if it makes a triangle. So 180 with the 50 degrees that we've already been given and the new angle that I found gave me a negative angle measure. I can't have a negative angle measure. So that tells me that this particular triangle is only one solution. Okay, so I can only make one triangle out of these given measurements. All right, let's look at number 8. Let's do the same thing. Okay, I've got a triangle. We don't know what's going on, so we're just going to set it up. Okay, angle B is 37 degrees. AB, which is going to be right here, that's going to be side C, is 47. Okay, then AC, which is going to be right here, this is side B, it's going to be 29. We're looking for angle C, okay? So here is my question angle, okay? All right, so we've got our B, we're looking for our C. All right, so let's go ahead, since we got both measures for B, we'll do the sine of 37 degrees over side B is equal to the sine of C over 47. Okay, do your thing. Do your cross product. 47 times the sine of 37 degrees is equal to 29 times the sine of C. So the sine of C is going to be equal to this. Now what we have to do is divide this out and make sure it's in between -1 and 1, because if it's not, there's no sense in going on. So we have 47 times the sine of 37 degrees, and we're going to divide that by 29. Okay, so I'm going to go out 4 decimal places, so 0.9754. So the sine of C is 0.9754. Do you see how that's in between -1 and 1? So that tells me I'm going to make at least one triangle. So now let's go ahead and find the inverse of this value so that I can figure out what angle C is. So inverse sine of all this jazz will give me 77.3 degrees. So angle C is 77.3 degrees. Okay, so that's my guaranteed one triangle. Let's do a proposed second angle. So let's find C1. So 180 minus 77.3 degrees is going to give me 102 7/10 degrees. Okay, so this one is an answer no matter what. Let's see if this one is an answer. So 180 minus the angle we started with, which is 37 degrees, minus 102 7/10 degrees. So if you do 180 minus the 37 degrees minus the 102 7/10, see how that's a positive angle? So that tells me that I'm going to have two angle A's and I'm going to have two angle C's. So this is my second angle, okay? So I've got two triangles for this one. In order to figure out if your second triangle is in existence, do 180 minus the angle you found. This is your proposed second angle. And then make sure it works. Make sure it makes a triangle. 180 minus what you started with, minus the angle you found, and if it's positive, it will make a second triangle. If it is negative, it will not make a second triangle. So since this one was positive, I have two solutions for C, 77.3 degrees and 102 7/10 degrees. So two triangles with two solutions. Isn't that awesome? Now let's look at number 10. Let's do the same thing. Let's build our triangle. We've got A, B, C, A, B, C. So angle A is 114 degrees. So this is an obtuse triangle. We know these two have to be acute. So AB is equal to 34. That's going to be side C. And then BC is going to be 12. That's going to be side A. We're looking for angle C. Okay? So side angle, just like these other triangles were, side angle. Now, let's set up what we've got. We're given A. So we've got the sine of 114 degrees over 12 is equal to the sine of C over 34. So let's do a cross product. 34 times the sine of 114 degrees is equal to 12 times the sine of C. All right, so the sine of C, let's go ahead and plug this right here into our calculator. So we have 34 times the sine of 114 degrees, and we're going to divide that by 12. Look at that, 2.5884. The sine of your angle has to be in between -1 and 1. Well, that's not in between -1 and 1. So what that tells me is it's out of my range. So no triangle can be formed from these measurements. Okay, so this is a no solution. No triangle, no solution. So with side-side angle, you can have one triangle, two triangles, or no triangle at all. Okay, so follow the steps that you have on your Word document, and I want you to do 9, 11, and 12. On 9, 11, and 12, you're going to have one of each. One solution, two solutions, no solution. Okay, so do those three. Take your time. Do a good job.